Thanks for joining, everyone. My name is Didier. I'm the technical lead for the HPE developer community. This is a meetup, and I'll talk about the different webinars we have as part of the HPE developer community. The meetup for this month is about private cloud AI, and it's going to be mostly demo-driven. We have with us Randy. I'll hand it over to Randy in just 5 minutes. Before I do hand it over to Randy, I'd like to go over the different webinars that we run as part of the HPE developer community. You can find all of these on our webpage, developer.hpe.com/skillup. This is a meetup, so basically kind of a technical, in-depth on technology or product session that we run on a monthly basis. We started this more than 2 years ago. We have upcoming session in May on computer ops management. And if you're interested about the current ecosystem for developing and using the APIs, that's probably a good session for you to attend. My colleague Denis in the background will provide you with all the links in the chat. So you'll be able to register for this immediately. I'd like to also welcome Joanne with us today. She will be helping Randy with some of the questions in the background. In addition to meetups, we also run another monthly webinar called Munch and Learn. Actually, this is the first one we started 3 years ago. And this is a little bit more like thought leadership, trying to be vendor and product agnostic when possible. We have a session in May on May 21st. Again, the links are available for registration. Denis will paste that in the chat. And this is about sustainability Insight Center and sustainability in general, how to win with your business and the environment. So interesting topic, I'm sure, for everyone, May 21st. We also started more recently a third series called the AI Jam. We are running this together with the people from the Octo Innovation team. And this started only in August, September, and we're going to have our 7th session, I think, on May 14th, and it's going to be about lesson learned in AI retail projects. So this is a bit different. It's run as a panel discussions with every time 3 or 4 different experts from HPE and a host as well to drive the discussion. Feel free to join with this for these discussions. The link is not ready for that one, but we have a web page. We will update that web page as soon as this is available. But we know the topic and we know the date. This is for webinars. We also have another way to learn new things, and this is what we call our workshops on demand. So this is a way you can get a platform allocated to you for a couple of hours to run through a driven workshop. We use Jupyter Notebook to deliver the workshop. We have about 30 workshops in the catalog, from programming Python, programming Rust, to what's an REST API, getting started with Kubernetes, we're getting started with Docker. We also have products, of course, such as OneView, ILO, and things like that. So an API for GreenLake, for example, is one that we added with our team. This is available 24/7. It's free of charge, and it's available to anyone with an internet connection. So give it a try. If you do, provide feedback through the survey at the end of the workshop. That's very helpful for us to find out what's missing from the catalog. Finally, this is a community, so it couldn't run without you to help amplify and contribute. So feel free to, of course, continue to join our webinars, but feel free to also invite others to join our talks, sorry. This is open to anyone, customer, partners, students, friends, colleagues. Feel free to invite. We also have a monthly newsletter that we send at the beginning of the month. And you can sign up through this URL. I know Denis has probably pasted the link in chat. You can register to this newsletter to be sure you don't miss any talks. Also, we advertise any new blogs that we released on the website. We have a dedicated workspace, Slack workspace, sorry, where people can ask questions. And of course, you can also, this is a community, as I already said, you can help customers or you can help answering questions on particular topic. Go take a look. You just need to register with that Slack workspace, and then you can follow the different channels of interest. We have a Twitter X account if you want to follow us. And if you're an SME, that's also something we'd like to hear, because you can help us with blog. We're always on the lookout for blog writers. We have a open source platform that allows people to write blogs in a pretty simple fashion. All you need is really a GitHub account. So reach out to us for writing blogs or participating in a meetup, like as a speaker, like Randy today. And finally, if you want to help with a workshop that you think is missing from the catalog, this is also possible. So feel free to reach out to any of us. The mail is also in the link that Denis has shared. And with that, these are the links, the important links you might want to get in touch with the dev community. There's a QR code that has all the links in one shot. And with that, I will hand it over to Randy for the rest of the discussion. Thank you. It's all yours, Randy.
Well, I want to welcome everyone to today's webinar on the HPE Private Cloud AI. I'm Randy Thomason, as Didier mentioned, and I'll be walking you through some of the key capabilities of Private Cloud AI. But before we dive into the demonstrations for today, I just want to take a moment to recap where things are at with AI and some of the challenges. Undoubtedly, the AI revolution is disrupting every industry, and whether you're talking about retail or financial services or healthcare, AI technology is rapidly reshaping industry, and companies are often struggling to stay on top of the wave and actually realize returns from their investments in AI. Granted, the potential rewards of AI are huge, but there's also a large number of challenges, with only about 1 in 10 AI pilot projects actually making it into production. And the challenges are pretty much everywhere. AI is all about models and data, but which models? And how do I manage the life cycle of these models over time, as well as the mountain of data that's required for these AI solutions to be effective? And then there's the tools that are often complex to integrate, expensive to operate, and somewhat difficult to maintain. And then how do I manage those tools, which is a growing set that changes and evolves rapidly over time. And once I've got a handle on the data, the models, and the tools, then there's also a question of scale. How do I scale my solution and my investments so that they can handle explosive user growth and new use cases? And finally, the cost. As I scale my solutions and investments over time, how do I manage those costs so that they're predictable and sustainable over the long term? Because at the end of the day, it's all about faster time to value and the freedom to be able to rapidly support emerging business needs. There are lots of challenges, and enterprises everywhere are looking for solutions that are simpler to operate and maintain while providing faster time to value, solutions that scale with growing needs and also a changing set of technologies, as well as solutions that provide enterprise-grade security that is built in and not just bolted on. And finally, solutions that have predictable cost so that companies can effectively manage their AI investments. The HPE Private Cloud AI is a solution to meet these challenges. HPE Private Cloud AI, which is part of the NVIDIA AI Computing by HPE portfolio, is a turnkey, scalable, and AI-optimized private cloud that's designed to accelerate AI adoption and deployment while ensuring that data remains within the control of the enterprise. It combines NVIDIA accelerated computing, networking, and software with HPE's high-performance compute, storage, and the HPE GreenLake Cloud, together with curated services that cover things like MLOps, data pipelines, orchestration, and processing. Now, today's webinar, we're going to focus kind of this middle portion of the software stack. So AI software and data foundation. This is provided by the NVIDIA AI Enterprise components and then also HPE AI Essentials software. And it's this middle layer that provides the key platform security, data analytics, and machine learning services that are needed to create, deploy, and manage AI solutions at scale. At its core, HPE Private Cloud AI is a solution that's designed to accelerate AI adoption, and it's made for the people that make AI happen in the enterprise. It's designed for administrators, the people that rack, stack, and manage the infrastructure, as well as those that are tasked with managing the data sources and tools, GPU resources, and users. Private Cloud AI is also designed for data scientists and ML engineers. And these are the folks that are tasked with experimentation, training, deployment of models in AI applications. And this allows them the freedom to focus on the capabilities being delivered rather than just the tools and the infrastructure required. And then Private Cloud AI is also designed for data engineers and data analysts, the folks who wrangle the mountains of data that are needed for AI at scale, allowing them to build data pipelines to process data, transform and visualize data, while at the same time reducing the effort needed to manage data infrastructure. So now that we've recapped the current state of AI and how HPE Private Cloud AI can help accelerate AI innovation, let's dive into the solution itself a bit. So I've logged into my HPE GreenLake console. I have a workspace up, and the workspace defines a set of resources for my private cloud. And in order to manage users, that's a management function of the workspace itself. I want to go to manage my workspace, and you'll see that there's a series of tiles here that allow me to perform various management functions of my private cloud in the workspace in particular. Among these is one that's called Workspace Identity and Access. I'm going to select that. And this allows me to manage the users, roles, and permissions, as well as being able to restrict the resource policy. I think it's worth noting that the actual provisioning of users and managing users within HPE Private Cloud AI is actually performed inside of the HPE GreenLake console. So it's just like any other GreenLake workload. You can add users, get a list of everyone that's currently defined. I can invite new users by providing an email address, selecting an appropriate role, and then sending out the invite. With users that have accepted the invite that are defined, I can then go and assign a new role. I'll select a service, in this case, my development service, the workspace. And you'll see that there's a wide variety of roles that are defined for my GreenLake Private Cloud. The roles of interest to us are the Private Cloud AI Administrator, the Private Cloud AI Cloud Administrator, and the Private Cloud AI User. These are the three roles that map to the capabilities of Private Cloud AI. And I just pick one of these roles if I want to assign it. And then once I've assigned the role inside of the GreenLake console, this is automatically provisioned across into HPE AI Essentials. So now I'm going to just jump over to HPE AI Essentials. And to manage users and actually assign resources and do finer grain definition of what they're able to do with AI workloads, I go to the Administration pull-out menu, Identity and Access Management. And then in this case, I'm going to select a user down here at the bottom, Jeff Martin, who is an AI user or a member in the tool. Manage privileges. And you'll see that from this screen, I can assign privileges relative to either structured data sets, object store data, again, which in this case, my S3 buckets are defined as public. So not really necessary for me to try to restrict access to the data in those buckets. If these were defined as private access instead of public, then this would be the place where I could go and select specific buckets and then assign specific privileges for this given user. And then in addition to the object store data and the structured data sets, I can also go and manage privileges to deployed applications. You'll see again that for each application, I can define either no access, read-only, or full access to the application. And so this is how I would go about assigning the privileges and managing users inside of HPE AI Essentials. And again, bearing in mind that the actual provisioning and creation of users takes place in the GreenLake private cloud. And then I've got some corresponding activity that AI administrators can perform inside of AI Essentials to provide a fine-grained definition and privileges assignment to various users. So when you think about the different types of personas and users that are supported within the system, again, Private Cloud AI makes use of 3 roles that correspond to key personas associated with AI solutions. A cloud administrator, and this was the person that we've showed that works inside of the GreenLake private cloud console. They're here to be able to add users and roles, access and observe, as well as expand the cluster itself with the infrastructure and the hardware. In addition to the cloud administrator, which does their work inside of the GreenLake private cloud console, there's an AI administrator. That's the person that goes in to AI Essentials and then is able to do a finer grain definition of privileges relative to specific resources associated with AI workloads. And then finally, AI developers who are able to interact with AI workloads, create their own objects, models, experiments, applications, pipelines, and so forth. And AI developers can then choose to share artifacts that they have developed and created with other users. Worth noting that one of the values and the ways that AI Essentials helps improve the security of solutions is through user isolation. In HPE AI Essentials, each user is assigned a personal workspace. This user-designated workspace isolates each user's applications and objects from other users in the cluster. Users can share their work if they want by setting access controls directly on those objects, like an S3 bucket or an application or a model. AI Essentials also integrates applications with different isolation mechanisms and assurances. This is an area, again, where AI Essentials really takes care of some of the plumbing for you. Instead of you having to deal with a myriad of LDAP servers or different RBAC control systems, say for like Airflow versus Spark versus Apache Superset, that heavy lifting is done for you by AI Essentials. That basically rationalizes the 3 roles within AI Essentials and maps those to the corresponding roles in like Superset or Airflow. And in other cases like Spark, where there really is no role hierarchy, it allows for isolation of work to managing the specific artifacts that are created in the different workspaces, similar to what happens with like MLflow or Kubeflow. Now that we've gone through the management of the users, another administrative task that I would like to be able to walk you through this morning relates to managing GPU resources. It's really no secret that enterprise class GPUs tend to be rather expensive and always in short supply. So it's vital to make the best use of those resources. And HPE Private Cloud AI has 3 powerful facilities that make GPU management a bit easier and more effective. GPU idle reclaim, a GPU custom Kubernetes scheduler, and the GPU control panel. For the GPU idle reclaim, this capability makes it easier to optimize the use of GPU resources. And there's a couple of important design goals behind the idle reclaim facility. First, we want to be able to optimize workloads by distributing GPU resources to the various workloads in the cluster so that each workload gets the needed computing power. Another key design goal is to maximize GPU utilization by dynamically allocating and also deallocating resources to frameworks and workloads as needed. And then also ensuring efficient use of GPU resources by ensuring that critical workloads, those that operate of fairly high priority, like say patching a model that's got to go into a production, that these critical workloads get the resources they need while allowing lower priority workloads to have GPU when it's available. In addition to the idle reclaim, HPE AI Essentials also provides a custom Kubernetes scheduler. Now, the architecture behind the scheduler is that this is a custom scheduler plugin that governs all GPU workloads, and it's installed in a specific namespace within the Kubernetes cluster. The namespace consists of both a controller and then a scheduler module. These containers basically manage the scheduling of pods that require GPU resources. In terms of the configuration, AI Essentials configures GPU-enabled tools and frameworks so that the custom scheduler is used by default. So all of the AI Essentials tools and frameworks that we provide out of the box that support GPU workloads make use of this custom scheduler. This includes Kubeflow, Apache Spark, Apache Livy, as well as Ray. And the scheduler runs a cron job that goes every 5-10 minutes that looks at the running pods and then determines the feasibility of reclaiming pods based on their GPU usage and the policy settings that govern whether or not this one can, a particular workload can be preempted. Now, to configure GPU resources so that we can have the idle reclaim and preemption, there are a couple of different parameters involved in AI Essentials. First and foremost, we set the priority level. And this is just a simple numeric value from 8,000 to 10,000, where 8,000 is the lowest priority, and 10,000 is the highest priority. Should be noted, this is not a reservation, so it's not like going into a hypervisor, like ESXi or VMware and making like a reservation of CPU. This is not reserving the GPU, it's assigning a relative priority to a workload. So for example, if I have a workload that is set at priority 10,000, that workload could potentially preempt and reclaim GPU resources from lower priority workloads that were running at, say, a priority of 8,000. In addition to the priority level parameter, there's also an idle time threshold. This is the maximum amount of time that the GPU can remain idle without running any workloads. Once a workload reaches this threshold and a GPU remains idle for more than this amount of time, then the GPU on those workloads can be reclaimed to make the GPU available for other workloads. The idle time threshold defaults to like 300 seconds, has a minimum of 60. And again, this is something that we configure inside of the GPU control panel, which I'll show you here in just a moment. Then there are two other parameters that we don't directly set, but that are also involved in configuring GPU resources within the platform. One is toleration seconds. That's the minimum number of seconds that a pod or workload needs to run before it can be preempted. So the way that this works, right, is that if I fire up a new workload, say I've got a model that's training, I can define a minimum amount of time that I'm going to give that pod to run before it would be subject to preemption, so that I don't just finish bringing the container up for the pod and then it's immediately preempted. Likewise, there's also a GPU usage threshold, which is the level of GPU utilization. The default usage threshold is 0, and this really is setting the floor at which preemption could occur. So basically, if I have a workload that I'm going to configure to where it can be preempted, that threshold is set to 0. So if it has to be completely idle before we're going to actually look at reclaiming an idle GPU and then preempting that workload and giving the GPU to a different workload. So real quickly now, let's just go back and I'll look at show you the control panel within the product itself. So to access the GPU control panel, which I've got up, again, I would go to the left menu within AI Essentials, go to the administration submenu, and then to resource management. And you'll see that I show a variety of frameworks. If there's any GPUs assigned, and you'll notice, for example, that I've got 2 assigned to MLIS, Machine Learning Inference Service, and that both of those are currently idle. Notice the priority level, as we mentioned before, is set to a default of 8,000, or it can go up to a maximum of 10,000. If I need to configure a workload and change from the defaults, I can set both the priority level, again up to 10,000, as well as the idle time threshold inside of the GPU control panel. If I have multiple GPUs assigned with a particular workload, I can often click on this and then get more specific details. So you'll see in this case, within MLIS, I've got two pods, one that's running a small Facebook model that's got a GPU assigned that's been idle for a while, and then another pod that's running a Llama 3.1 8B instruct model. And again, from those actions, I could look at a GPU utilization chart to get more fine-grained definition of what's going on and how much that particular GPU is being used by a particular component or workload. So that's the GPU control panel. Next, I'd like to look at how data engineers can use HPE AI Essentials to help in their day-to-day work. Now, data engineers typically spend a lot of their time wrangling data. That is, when they're not wrestling the infrastructure. And AI Essentials helps ease the burden of managing the infrastructure associated with this mountain of data while making it easier for them to ingest, process, and visualize the data. And the scenario that we're going to walk through together today is just a typical day in the life of a data engineer using Apache Airflow and Apache Spark to construct a simple data pipeline for processing data in HPE AI Essentials. Now, within HPE AI Essentials, there's a couple of different palettes of tools, which we'll show and walk through in a moment. But I think it's worth noting that this is a rich set of tools that comes out of the box. You can extend the set by adding your own frameworks, other types of open source tools, but out of the box, for data engineering purposes, AI Essentials provides Apache Airflow, which is a popular open source tool for authoring, scheduling, and monitoring data pipelines. Provides Easy Presto, which is an HPE customized version of the PrestoDB, kind of an open source distributed SQL query engine that's meant for doing distributed queries against large data sets. And then finally, Apache Superset, which is an open source app that handles data visualization and data exploration. In addition to the data engineering palette, there's also a data analytics tool palette. And out of the box, this includes things like Apache Livy, which gives us a RESTful interface for interacting with Apache Spark clusters, the Spark History Server, which is a web UI for looking at completed and running Spark apps, and then also the Kubernetes Spark operator. And this provides a UI for inspecting and editing and managing Spark applications that are running within our platform. So next up, we're ready to kind of construct and run through our data pipeline in Apache Airflow. To get to Airflow again, I can go to my tools and frameworks, data engineering or analytics. You'll see I've got a series of tiles, including Airflow. So I'm just going to click the open button on Airflow, and that will bring me up to my Apache Airflow user interface. And again, I don't have to worry about integrating or propagating credentials or and privileges across these different tools. That's done by the platform. This is just your standard, Apache Airflow UI. It defaults to the list of DAGs that are currently defined in the Git repository that's configured with Airflow. And we're not going to spend a lot of time going through all the configuration, but from tools and frameworks, I can also go within AI Essentials and then configure it, right, to point towards a Git repo, set up the replicas that I want, the resources allocated, and so forth. So even though there's an out-of-the-box deployment and defaults for things like Airflow or Livy or Spark, I can always go in to the Tools and Frameworks tab of the settings within the administrative functions and then tweak or alter those settings as needed. Now, inside of the Airflow UI, again, I've got a list of DAGs. These are the DAGs that are actually in the Git repo that's been configured with Airflow. In this case, I want to select the Spark Read CSV. And this gives me the details associated with the particular graph or DAG. You notice on the left, I've got a histogram that shows me a variety of different runs that I've done over time, as well as their status. To the right is a pane that provides a little bit more detail about some of these runs, number of successes, the number of failures, total number of runs, and other metrics. In addition to the details of my DAG, I can also get a graph, Gantt chart, or I can look at the code. In this particular DAG, it's a fairly straightforward pipeline. I have a set of parameters that are provided to govern the processing, things like the export path, where I'm going to write my Parquet file out to, the S3 endpoint, where I get the input data from, the particular bucket name. And then you'll notice that in terms of the actual pipeline, there's just really a single operator. I'm using the Spark operator for Kubernetes to actually kick off and launch my Spark job. And my Spark job is going to read some comma delimited data from an S3 bucket, then transform it and write out a Parquet file that I can then pull into my notebook and do some visualizations with. In addition to my code, I've also got event logs where I can go and look at, again, different runs historically, status, run duration. So you see I've got one anomaly. I think in this case, I actually had too many pods deployed, and so it kind of hung up. The actual task duration, and then also a calendar, right? That shows what's been running. So once I'm ready to actually launch my DAG, from the details, you'll see I've got a button up here in the top right that triggers the execution of this pipeline. So I'm just going to click that. You'll see that those same parameters that we looked at in the code are provided to me again, so I can override the values that are a part of the definition of the pipeline if I need to do a runtime substitution just before I execute it. I'm going to click trigger to fire this off. And then that particular pipeline is going to run to completion and execute. And then once I've got the pipeline execution completed, I can bring it up and look in a variety of tools to look at Spark apps. And as I mentioned earlier, AI Essentials provides a couple of different tools. And again, these are accessible off of the analytics palette. And I've got a Spark history server as well as the Spark applications. So let's look at the history server first. You notice that within the history server, I've got a series of runs listed. It should be noted that because of the nature of Spark security, this list is going to include all the runs from all the users. It's just that I won't be able to interact, like edit or to change or to inspect application runs that aren't my own, that I didn't create. Now, in this case, I'm an administrator, so I have basically super user privileges and can inspect any. But if a particular user was just an AI user or a member in AI Essentials, they would only be able to interact with the runs that corresponded to, Spark apps that they had created and started. And you'll see that within the history server, again, this is just the standard history server UI. I've got a list of the different job IDs, details associated with that, whether they were successful or not. So just a standard Spark history server, but again, right here at my fingertips. In addition, I can also look at a Spark application summary that would list all of the different applications that I've run over time. In this case, I've just sorted by the date to get my most recent run. I can select that, and then over to the right, I have a variety of choices. I can view the details of this run. So I can see, for example, that there was a driver pod, 2 executor pods, that these all completed. I get the driver settings, 1 core, half a gig of RAM. Same for the executors, 1 core, half a gig of RAM. And I can see that the application status is completed. In addition to viewing the details of the run, I can view the YAML itself that defines my Spark app. So things like resource settings, mount paths for volumes, settings on my executors, the Hadoop config, all of that's accessible. And in addition to just viewing the YAML, I could edit it. I can also view the logs associated with the execution of the Spark app. And I could also clone an app, schedule an app, or delete an app. And again, all of this is something that's just provided out of the box. So there's no additional, integration or tie-ins with security. And in this case, my application I'm working with, again, are going to be constrained on, to the set of applications that I myself have authored. Now that I've done my pipeline, I'm ready to pull it up into my notebook and to visualize some of the data. So you notice again on the left pull-out menu, my fourth choice from the top is notebooks. This has a list of notebook servers. In this case, I'm going to select my notebook. It is worth noting that each user that is provisioned into AI Essentials is provided their own notebook that's pre-integrated with both shared and private storage and also secured. So I'm running in my own workspace. My work and stuff that I'm doing in my notebook is by default isolated from other users, so we don't have to worry about stepping on each other. And again, this is assigned to me as an individual user. I also have a shared storage where I can go to if I've got things like tutorials, like this one, for example, Financial Time Series tutorial. And because of the nature of integration between the notebooks, which in our case are backed by Kubeflow notebooks, the data sources, including the GreenLake file system, our object storage, and as well as structured data sets, it's fairly straightforward and easy to just simply declare a secret or two, copy a token, and then I'm ready to go in terms of starting to visualize my data. And again, what we're visualizing here is just a series of stock market close information. And this was read initially from an S3 bucket by our Apache Airflow pipeline, right? Transformed, written out to a Parquet file. And then what I'm doing in my notebook is I'm accessing the Parquet file to visualize the data. It's probably also worth noting, as far as the notebook servers go, that these notebooks are also effective in terms of being able to share scarce resources like GPUs. Now, in this particular example, I don't have a GPU allocated, but if I did have a notebook that had one or more GPUs allocated to it, and there was a member of my team who really needed the GPU to, again, say, work on a patch or to do some, time critical training of a model or whatever, I could basically go and stop my notebook. Now, what's interesting about a Kubeflow-based notebook like this is that when I stop it, it actually scales down my pods in Kubernetes and turns loose of my GPUs and my CPU, my compute resources, without actually deleting the notebook, right? So after my teammate is done doing their time critical work, right, and they're done and I can have the GPU back, I can simply go back and resume my notebook and pick up where I left off. This is a powerful feature that allows me, again, as an administrator, to ensure that my data engineering teams and my data scientists can make effective use of GPUs without it being hogged, because those are, again, fairly expensive and they're in somewhat short supply.
So Randy, could you answer a question quickly before we move on?
Sure.
One of the questions was on the AI worker nodes, what flavor of Kubernetes is running?
In terms of a flavor, it's basically an HPE adjusted version of the CNCF, just an open source Kubernetes, right? So was it easy KF? And again, just to recap again from our demo. So we saw how we could employ Airflow to run a data pipeline that launches a Spark job that processes, S3 object data and then visualizes that data in a Jupyter notebook. And again, it's worth noting that Airflow the Spark Kubernetes operator, the application UI, the history server, Jupyter Notebook software, it was all pre-configured, deployed, and ready to use. I didn't have to wrestle with bringing online additional infrastructure, configuring the tools, configuring security, or worrying about single sign-on and differing security models between, say, like Kubeflow and Apache Spark, as an example. And this is all part of the lifting that AI Essentials does for you, which is considerable. And again, like most plumbing, it's not sexy to look at, but you're really glad that it's there. When you push the lever or turn the faucet, you just want things to go where they're supposed to go, without having any additional hassles or a mess to deal with. Now that we've taken a look at how data engineers can use AI Essentials to help make their lives a bit easier, let's look at how machine learning engineers can also use AI Essentials in their day-to-day work. ML engineers often work with a wide variety of tools and data. And again, they often find themselves wrangling the infrastructure because of the rapid way in which these tool sets evolve and just the complexity and nature of the tools themselves. AI Essentials eases this burden by providing a rich palette of machine learning tools out of the box where this has been pre-integrated, security's been handled for you, and it's simply ready to use. So in this particular scenario, we're going to walk through a typical day in the life of a machine learning engineer using HPE MLIS to package and deploy a machine learning model. And then we're also going to take a look at some of the solution accelerators that are provided by HPE AI Essentials. And again, there's a fairly rich palette of tools that are provided out of the box. And these include Kubeflow, and that's an open source Kubernetes native platform for managing the life cycle of machine learning models and artifacts. And again, it is Kubernetes native. MLflow, another open source platform to manage end-to-end machine learning lifecycle, really with a sweet spot dealing with experiment tracking, model packaging, and deployment. The one that I just mentioned a bit earlier, HPE MLIS, which is the machine learning inference software platform that helps expedite the development and scaling of AI models and applications, and particularly tailored towards generative AI. And then also Ray, which is a distributed compute engine that's kind of like Spark, but also offers better task parallelism, whereas Spark exceeds at data parallelism. So that's kind of the palette of the tools. So again, we're going to go into the product itself. I'm going to go to my palette of tools and frameworks, data science. Within HPE MLIS, which again is a machine learning inference service, I can create registries, I can package up models, and then I can also create deployments and define access tokens. So first up, in terms of being able to package up a model and create a deployment, would be to have an appropriate registry. I can add a registry by going over here to the right, click Add New Registry, give it a name. Provide a type, and you notice there's 4 different types supported. Basically, anything that supports, an S3 protocol can be used as a registry. So the most basic form would just be like an S3 bucket. Also supported are OpenLLM, the NVIDIA catalog or NGC, and then also an HPE PFS format. In this case, I'm going to select OpenLLM. You'll see that the default one out of here is over to Hugging Face. I can plug in an access token that corresponds to, say, like a Hugging Face account for a team or me individually. And then I can create the registry. And you'll see that I've got a number already defined. Including an NGC or the NVIDIA catalog, and also some Hugging Face. Once I've got a registry created, I'm ready to go package a model. You'll notice that when I select package models from my left menu, it'll list out all the current models that have been packaged and then show you my status, whether it's currently deployed, whether it's staged but not currently part of the deployment, or whether it's in the process of being deployed. In this case, we'll add a new model. I'll give it a name. Oops. Define the storage characteristics. And again, in this case, I pick the registry I want to use. I can now either pick a model from a list, and these are already vetted and curated, or I can just pull a model directly from the Hugging Face repo. You'll notice that the primary difference between these two choices is that the model from the list of vetted foundational models is likely going to be a little bit older on the versions than just pulling directly from Hugging Face itself. And you'll see there's a long list of different models available. In this case, I'm going to pick a small Facebook model. I can supply an alternate container image if I need to do something different than the default container image for this particular model. In this case, the default one's fine. Click Next. Now I can choose a resource template, which defines the compute resources required for this model. Excuse me. I have a variety of both CPU only and GPU enabled. In this case, I'm just going to pick GPU Tiny. That gives me a single CPU, 10 gig of RAM, and 1 GPU. If none of these pre-built templates satisfy my needs, I could always go custom and then specify my own compute resources. Finally, I can supply either environment variables and/or command line arguments that are needed to go with my model, and then create the model. And you'll see it up here, and now it's showing us status of being staged, which means that it's available for being deployed, but it's currently not in any deployments. At this point, I'm ready to create a deployment. Again, when I select deployments from my left menu, you'll see that the list of all the different deployments and deployed models is provided, including my status, whether it's paused, whether it's currently deployed and running, if there's any associated errors, and what my latest event is. The namespace involved, and I've got two models here myself. The model that was packaged in the deployment, in this case, right, the small Facebook 128 meg, and then also the Llama 318B Instruct model. And then to the far right is the endpoint that I can use within my applications to make API calls to interact with the model. To create a new deployment, I click Create New Deployment, give it a name, pick the model, assign infrastructure whether or not I'm going to secure it. For the purposes of AI Essentials, we always enable security, so that particular option is grayed out for you. On scaling, I can pick again a scaling template between fixed profiles that scale based on concurrent use, and then profiles that scale based on requests per second. In this case, I'm going to pick a simple one, just fixed. That's fixed it at one instance, doesn't really scale up. Again, I can define my variables or my arguments, and then I'm off to the races and it's deploying. Once it's actually finished deploying, it'll show it up as being serving. And so that's how I would go about packaging a model and then deploying it with MLIS.
So Randy, we have a couple of questions.
Sure.
Can you configure Slurm in PCAI?
No, I don't believe so. So in terms of the container mechanism we have, instead of like Slurm, it's, you use Containerd and it's a standard Kubernetes distribution. And we don't have the ability to accommodate Slurm at this time.
Okay. And then when you select a model, can you decide quantization levels?
The profiles are something that we would do likely inside of the container configuration for the model that was packaged, as opposed to something that's exposed directly as a parameter inside of the model itself. Hopefully that makes sense. So inside of take for example, the Llama 3.18 billion. There could be a variety of profiles associated with that represent different levels of quantization, whether it's 4-bit, 8-bit, 16-bit. And then that would be that set of profiles available packaged as part of the container. We don't expose that directly inside of MLIS in terms of an option to, if you will, adjust the container that's being used. The way that we would typically handle that, I think, is to use an alternate image, a container image, if you wanted to, force a particular profile that had, say, like 8-bit quantization versus 16 or something.
All right. Can you configure applications which run as an operator in Kubernetes?
So in terms of adding applications, which we haven't really looked at too much, but I can go into my I have the ability to import applications, and I was going to see if I had an example of that. I think I do. Let me look at one of my palettes. So you'll see that some of these banners say imported, like CoCalc and the Pod Manager in MySQL. Basically, I can import a framework, right, by giving it a name, providing a Helm chart, supplying an icon, and I could introduce applications that essentially provide or are like an operator. For example, you could take the Helm chart for the NVIDIA NIM operator if you had, appropriate licensing from NVIDIA, and then you could take that NIM operator, import it as an application, and make it available as a part of the palette inside of AI Essentials. So just real briefly, because I know we're at time, I wanted to show you a little bit about our solution accelerators. And you'll see that out of the box, we provide a RAG Essentials, which is retrieval augmented generation, where we've done some of the lifting for you again and providing kind of a template for deploying RAG-based applications, where we handle the embedding model, wiring up a vector database, in our case, Weaviate, and a broker client, the large language model, which again could be one of the NVIDIA, like 8B instruct or 3.18B instruct. So all of those components are basically templatized so that what I basically do is select the model, select my data source, put my resource settings, and then deploy it. And two other out-of-the-box solution accelerators are a text simplification app. And the text simplification app uses prompt engineering, where I can import, say, some complex jargon or text, and it uses prompt engineering to provide a simplified rendering of the text for that particular application, and then also a virtual assistant or a chatbot. And so within the chatbot, I have the ability to augment what the model knows inherently what it's been trained on with additional context by uploading files. And in this particular case, right, I've got a couple of data sheets for our DL380 servers, so that when I'm asking questions from the chat bot, and without the knowledge base, I get a different type of answer that's generally a bit more vague. Take a while for it to cook up the first one here. And then once that, if that answer is not sufficient, like I said, then you have the ability to be able to switch in and use the private knowledge base, which pulls in the additional context to augment what the model has actually been formally trained on, which is often a more expedient and time-effective way of being able to enhance the capabilities of a large language model without having to necessarily retrain it and go to the time expense of doing that. So in a nutshell, that's it for our webinar today. I know that we're a little bit past on our time. I want to thank everyone for taking time out of your day to attend.
And
yeah,
I would
hand it
like
back to
to
you.
I would like to thank Randy for the demonstration. Thank Joanne for answering so many questions. Thank you everyone for joining. We are a little bit late. And if you have another few seconds, feel free to answer the question in the poll, just to give us feedback. And with this, thank you everyone, and we'll talk to you in the May webinars. Thank you, everyone.
Thanks, everyone.